Welcome to TPM's 3-Minute Thursdays. My name is Robbie Hoyler, and today I want to answer the question for our customers, can SOLIDWORKS Simulation handle my materials? I also want to identify which packages can handle which materials. I will explain each material input so you can pause the video and compare your material data with what I have on the screen. Use this video to help you identify which material data sets are required for SOLIDWORKS Simulation. SOLIDWORKS Simulation has 3 different packages: Standard, Professional, and Premium. Inside of Standard and Professional, you'll only have access to linear elastic isotropic and linear elastic orthotropic materials. An isotropic material is basically a material that has similar properties in all directions. An orthotropic material is like wood, where it'll have a different strength and compression and tension, and it has to have 3 perpendicular planes of elastic symmetry for it to qualify as an orthotropic material. For all material models that are not linear elastic, you have to use SOLIDWORKS Simulation Premium. We have a lot of different material models here on the screen, and I'm going to go through quite a few of these as we go through this video. So let's take a look at some nonlinear elastic models. If I go down to Delrin, which is actually a nonlinear elastic model, then what you need to have for the nonlinear elastic model type here: Poisson's ratio, thermal expansion coefficients, mass density, and tensile strength. Now, for any material that you put inside of simulation, you need to make sure that you have some sort of data that you can enter inside of these tables and curves. So really quickly, for a non-linear material, some thermoplastic or anything like that, you need to have some of these charts like this. The best one in this case would be the stress strain curve, but you can also find density versus temperature, Poisson's ratio, and XY versus temperature. And if you have these data points and these data charts in Excel, you can import them. Now that you know how to find the required tables and curves, we're going to take a look at some other material model types. We're going to look at neoprene, which is a hyperelastic model type. And inside of SOLIDWORKS Simulation, we have 3 different hyperelasticity types that we can use. We have the Mooney-Rivlin model, we have the Ogden model, which is used for incompressible materials, and then we have the Blatsko model, which is used for compressible materials like foam. The Ogden model, in this case for neoprene, this is a rubber, so we're going to use the hyperelastic Ogden type model. And some of the required curves for the elasticity types that we're showing you here, you can find the simple tension, the planar tension, and the biaxial tension curves for these models, and that is what was required to put that hyperelastic material inside of SOLIDWORKS Simulation. You've probably noticed throughout this video that I've been skipping over these plasticity models. Plasticity models are reserved for when you exceed the yield strength of the material, and the models that we have inside of SOLIDWORKS Simulation Premium are the von Mises model, the Tresca model, and the Drucker-Prager model, which is used for sand and gravel and things of that nature. So if you're operating outside of the yield strength of the material, you'll see some people that will run in large deflection mode and linear static analysis. But if you really want to see what's going on in the material outside of the yield strength, you really need to have SOLIDWORKS Simulation Premium and run some of these plasticity models. Now, for the plasticity models, you again need to go in to the tables and curves, and the best thing you can do is find the stress strain curve for that material, place it inside of SOLIDWORKS from an Excel file or something similar, and then you can run the simulation and get accurate results even past the yield strength of the material. Some other material models that we have access to inside of SOLIDWORKS Simulation Premium include viscoelastic models, where the rate of loading will really define the response of that material. And we also have the capability to look at shape memory alloys like nitinol and things of that nature. So if you can find the materials, which may seem like a daunting task at first, but there are several databases that SOLIDWORKS can actually access and import different material data curves from. It doesn't take that much effort to get this material in there, but finding the material can sometimes be a bit of a pain. But more often than not, if you have a material like that, you can ask the manufacturer for a lot of the material properties, and then they'll provide. In some cases, they'll even provide the stress strain data that they tested in their laboratory. So if you can find any ASTM guidelines for that material, that has been tested in a lab, you can use that, import that into SOLIDWORKS, and use that for your simulation. This has been TPM's 3 Minute Thursdays. Thank you, and we'll see you next time.